The next auton I'm going to talk about is our 9 block mid-season auton. So this was relatively similar to the early season one, except it was faster and way more competitive and was built on a different bot. So after our first two competitions, we realized that the structure, the S bot kind of structure with the angled C channel was kind of unoptimal with the wing placement. And you wanted a really boxy wing so that it could be really solid. So we rebuilt our robot to follow that kind of structure, and then made this new auton with it. So, and that's also when I added distance sensor reset functionality. So this is a more modern auton, and it was built on traction wheels. So I'm just gonna play a video of it really quickly. This video was taken at the Lockport competition, and yeah, let's just see what this auton looks like. Yeah, so as you can see, it kind of just dashes for those blocks, goes to middle goal. I think it had low air, which is why it was leaking at the time. Picks it up from the match loader, scores them, drives out, and then does a wing movement. So yeah, we could just watch that again. Going in really quickly. Yeah, I did spend some time tuning it to not cross the auton line. That was relatively important to me. I never got called on it, which was good. And then the next video I'm going to talk about, or the next video showcasing this auton, is this video when we were paired with 355Z at Lockport. One thing notable about this video is that it missed the middle goal alignment, and so like obviously my autons like aren't perfect, and so like that's one of the things that like I would say maybe tractions were worse at, was kind of just this issue with that if you had field variance it would be less like resistant to it, or maybe that was, I think that might have been just a function of our aligner at the time. But another thing I want to talk about in this auton specifically is that it was redundant. So one thing I had actually planned for stuff like this, and obviously I don't have it continuing on that on that outtake parameter as it's backing up. It's being told to lock it in place. So I do predict that like sometimes this stuff can happen. And instead, just go and score them all in the long goal, since we knew that our robot was relatively consistent at holding higher amounts of blocks at that time. Another thing I want to talk about is the end movement right here. So the wing movement, it's really different in comparison to our more modern wing movements that we had when we were on Omni wheels. And the reason this was done like this is because we had one tracking wheel at the time, and we had like some issues with our distance sensor resetting. So instead of like turning off of the goal and then swinging into position, which is what I would do more modern, since that would like use the leverage of the bot against the goal to cover more distance in a shorter period of time. The wing alignment on our modern autons were under a second actually. This one, because of the traction wheel limitation, because we only had one vertical tracking wheel, and I didn't want to use DSR in this specific movement, I had it back up and then drive forward, which was like relatively consistent. It was a little shaky, but I'd say it was decently good for what it was. And I think that it actually used two different pose movements. So yeah, and we're gonna go look at the code for these autons right now. So what does this look like? I haven't actually looked at this as of recent. So this was definitely the elims. Let me see. Yeah, so this is definitely this auton right here. So it starts out with setting its location using DSR, and since the places that we were at had plastic fields when we competed at Lockport, we competed at Niles, and Bodsoon for that matter. All those fields they were plastic, so we were able to use DSR. I'll talk about metal fields and DSR in a second, and where cannot be used. But essentially, we followed the same set of procedure for this, and it would use DSR to set its location. The first thing it's going to do is the first thing it's going to do right here is it's going to set its conveyor intake speed and exhaust speed to whatever the index speed was, which for this bot seemed to be 20%, and then full power, obviously 127. The next thing, 2 move to points, which was different than the original auton at 2 move to poses. So the reason I used move to point is because I realized that move to pose required an ending theta parameter, and the thing about these 2 move to points being chained is that they were faster and more fluid. So, and the ending theta wasn't really important, since what really mattered was how far your robot went across the line, and not exactly what angle it ended at. So changing the ending angle on the second movement wouldn't really change how much it went over the line. It was more or less a function of what the coordinate was for that certain thing. So these movements are actually pretty simple. The first one is just a min speed of 30, which I thought I remember it being higher, but whatever. Move to point is generally fast on its own, so that's where I think that came from. And then the first one's 600 milliseconds, next one's 900 milliseconds. We look at the coordinates for this. Negative 26.5, 1850, negative 5, 42, 0. Let's look at that. Negative 26.5, 18.5 coordinate itself in path.jrad.io. Negative 26.5, 18.5. Yeah, so as you can see, this actually was a setup coordinate. So it wasn't the blocks itself, it was setting up to go to the blocks itself. Mostly because I really cared about it being in the right location. It might have taken an odd trajectory at some point, and it might have been like, here, I'm gonna start here, so I'm gonna hit it, I'm gonna go to the thing like this, and it would miss like that block, or it could miss these blocks if it was a little under, since move to point does have variance. So I try to make it a setup parameter, and it would kind of just go into it, and it would have to be at a relatively accurate position on the setup. And then the next thing, of course, was just going here. I think if I can remember correctly, the coordinate for that one was negative 5 on the x. So it's getting relatively close. But since I had a lot of early exit, well, there was no early exit range, but I think it might have been the timeout actually saving this one. It would get close, but it wouldn't get too close, obviously. I think I did change it a couple comps just because I was nervous it would go over line, but it never ended up doing that, so we were relatively fine. We ran this Auton a lot, and I'd say it was relatively successful. We ran it at Niles, we ran it at Lockport, and it did really, really well at both of those competitions. We never had to change anything or even run a different Auton since it was so dominant in its category. So as you can see, these are all the locations that we had. I don't really feel like inputting them right now since I kind of like lost the file for the path.jrad.io thing. But as you can see, they're relatively simple. One thing I would say is the match loader coordinate is relatively far back. So I don't think I was using tank to push myself into the match loader, which is something that I would consistently do with our other robots. I would use the tank parameter while it was going into the match loader just to give it a little bit of force so that it would be more consistent. As in a match, when you're going against a match loader, you kind of just don't sit there. You're kind of pushing it a little bit, or you're moving your wheels, you're jiggling, or something to keep it moving and keeping those blocks coming in just to make it more consistent. I don't think I was doing that for this case, but we can go look at it actually. So yeah, another thing I want to talk about is our middle goal high movement. So that one obviously has a tuned lead parameter. So what lead does is it changes the linearity, or not the linearity, but the curvature of your movement. So for example, this is really annoying. But like, let's say for example, I'm right here and I'm going into right here. So basically all that lead is the more lead that you have, the wider of an arc it's going to take, and the less lead you have, the less of an arc it's going to take. And since aligning to the middle goal was relatively important to me, and I wanted to be at the correct angle before it got to the long goal because I wanted it to be more consistent, I had a higher lead parameter. So what that looked like is I would basically be setting lead higher, it would make a tighter curve, and it would be at the correct angle for it earlier in the time. So this was a move to oppose command, and you can tell by the tuned lead parameter. And then right here, I set the command to async itself, and then I would have it reverse at half power for an entire second, wait for 300 milliseconds, and then all that basically was doing is a simple setup to essentially wait for the robot to basically back the blocks up, since the blocks needed to be backed up before they could be put in the middle goal. So you couldn't just use middle goal activation without backing them up, since we had a double roller design at the time. And then this was our double roller movement. It used also time, since our scoring was really, really consistent on middle goal with this block, we were able just to use time stuff like this. And then trapdoor was our pneumatic piston that would go down to enable that. So yeah, it would just move the exhaust to 80% power, or negative 80% power, and then the conveyor at 65% power. Next thing, the match loader approach. So this also had tuned lead and some min speed. Oh, I did actually use tank, so negative 55. So that would be around 35-40% power. So yeah, so I was basically just using some tank to push it into the match loader, and then I was using a little bit of higher lead. As you could see, one thing that we did happen maybe once or twice, I think, is that because we set the lead too high on our approach to the match loader, it would kind of ding the goal, but it wasn't really that big of an issue. I think that's also why we had a very high coordinate for the x coordinate for the match loader because it would as you can see, it goes on that little outer arc before it prepares to go on the inner arc, as you can see right here. So setting the coordinate back really far made it like hit the correct angle, but at the same time it wouldn't ding the goal. So yeah, we try to keep the lead higher just because your approach angle to the match loader is really, really important. Obviously, if you hit the match loader at a side angle, you're going to need more power to push it back, and that's really hard to programmatically implement. So really getting that approach right was really important for us, and I was able to accomplish that by setting the coordinate back and having that high lead parameter so that it would come in and approach it at the correct angle. And then I used some tank. As you can see, the wheels aren't moving, but they are applying force. Yeah, and then it goes up to the goal. I think that's... let me check the movement type on move to pose. Okay, so yeah, that is an issue with move to pose. It's the same thing. It obviously accumulated some air. Might have been because of drift. I do believe I distance reset at the match. Oh, I did not. Oh, whatever. Yeah, but I'll go to long goal, move to pose since I wanted the approach to be slower. And yeah, so that was like one issue, I guess, because the thing about move to pose is that instead of making a direct turn, it kind of does a swiggle. If you look at the boomerang algorithm on Desmos, it does like this little curve, and what move to pose is trying to do is trying to follow that curve, that mathematical curve that it defines. So that's why it looks a little wiggly. I think the better movement would have been move to point here, but I think I just kept move to pose since this was an adaptation of that earlier auton, and I mean, I guess it worked. Next thing was yeah, so the goal alignment. Moved to point on the way back since the angle didn't really matter. I kind of just needed it to move back. And then two poses to go to the initial position, and then another pose to go to the final position. So the reason I did that with the initial position is because if I only set a final position, it would try to go through the goal, which it obviously can't do. So it set an initial position with a desired heading, and it would hit that, and then it would go over and push itself farther into the goal. So yeah, that's really just going over that auton specifically.